In this section, we're going to be talking about Venn diagrams and set operations. So to get started, the universal set, denoted with a capital U, is the set of all elements in interest in a particular discussion. So you may have different universal sets for different problems. Then we have what's called a Venn diagram, and that is a visual representation of sets. You've probably seen Venn diagrams before, even if it hasn't been formally in your math class. You've probably seen silly ones on the internet before. So the universal set in a Venn diagram is represented by the outer rectangle, and then subsets of U are represented by circles inside of that rectangle. So here are a few of the basics of Venn diagrams. The first image represents A equaling B. So notice we have the rectangle U, and inside of it we have a single circle representing both A and B. So A and B are then two sets that are completely equal to each other. They're the same set represented by the same circle. Then we have A being a proper subset of B. So notice in that one, the smaller circle A is completely contained inside of B. So every element in A, if it lies inside of A, then by necessity, it would definitely be lying inside of B at that point. If it's in this smaller circle, it's definitely inside the bigger circle. However, the two sets are not exactly the same because there could be something outside of A but still in B out here. And then we have the cases where neither set is a subset of the other one. So that could manifest a few different ways. You have your rectangle U, your universal set, and you have these different A and B circles floating around in there. They may overlap, they may not, but one of them is not contained inside of the other one. Okay, so this leads us to set relationships. And the first set relationship we want to talk about is the set union, or the OR. So when you see union, that means OR. If A and B are sets, then the union of A and B is written A, and this it looks like a U shape, and then B, is the set of all elements that belong either to A or to B or to both. Okay, so where is the union in a Venn diagram? So if we want to, what we usually do with Venn diagrams is we shade them. We shade the appropriate spots. So where would we shade in this Venn diagram to note the union? Where would we be inside of A or B or both? What we end up shading in that case is everything inside of any of the circles. If you are over on this left-hand side, you're inside of A. If you're over on this right-hand side, you're inside of B. And if you're in this overlapped middle part, you're inside of both A and B. So anywhere inside of any of those circles would count as the union. The set intersection is the quote and of the sets. So if you have your two sets, A and B, the intersection is written as A, and then it's like an upside down U, B, that's the intersection symbol. Then the set of elements, these are the ones that belong to both A and B. So if you're going to be in the intersection, you have to be in the set such that you're an element of A and also an element of B. So and is the key word here. That's simply the overlapped part of your circles. That's the only place where you're inside both A and inside B at the same time. Now, two sets could be called what we call disjoint sets. So sets are disjoint if their intersection is empty. And what that means is that they have no elements in common. So if you have two circles in your universal set that do not overlap each other, they are completely separated with nothing in common, those are called disjoint sets. And then we have what we call the complement of a set. So if you have your universal set, and A is a subset of U, so you have your A circles inside your universal set rectangle, then the set of all elements that are in U but are not in A is called the complement of A, and we denote that A with a superscript C. Other ways that sometimes that's denoted is A with a line over the top. That is a different notation for A. I also know that sometimes they do it A and then like a little apostrophe, A prime. Those are all, again, based on which book you're looking at or which video you may be looking at online. Those are all different ways that they might note the complement of a set. I use the superscript C. So that's all your elements in your universal set, but not in the set that you're discussing. So basically what that looks like is everything that's inside the rectangle, but outside of the A circle. The other stuff, the stuff that's not in A. Okay, so let's go ahead and now that we've defined all those and we know what they look like visually, let's do some with some sets here. So we have set A being the elements 1, 2, 3, 4, set B being the elements 2, 4, 6, and set D being the elements 1, 3, 5, 7. And then we're given that the universal set for this particular scenario are the integers 1 through 10. And we want to find the following. So the first thing we want to find is A union B. So what I always end up doing when I see this or this union symbol, I always write the word or down here. Okay, so I want to write down the set. So I'm going to say A union B equals, and then I open up a set of braces. And what I want to write down is every element that is in A or in B. So 1 is in A, 2 is in A, 3 is in A, and 4 is in A. Now I go look at B, I already have 2, and I already have 4. I don't double list, so the only additional element I need to write down is 6. And that is A union B. Okay, the next part says to find A intersect B, and I always write the word and with that one to remind myself. So that's going to equal the set of what do A and B have in common? What's in A and in B? We kind of noticed from doing the union above that 2 and 4 were repeated. They were in both. So those two elements make up our intersection. Okay, what about the set A complement? What is not in A? So not in set A, but still in the universe that we're talking about. So our universe are the integers 1 through 10. If A is 1, 2, 3, and 4, then everything that's not in there is an A complement. So what's in A complement? That would be 5, 6, 7, 8, 9, and 10. The rest of those. Okay, our next one is A union D. So again, union is an or. So what elements are in A or in D? I'm going to start the same way I did the first one, which is just write down everything that's in A. So 1, 2, 3, 4. And then add in here anything that's in D that I haven't already counted. So I've already got 1, and I already have 3, but I haven't counted 5 or 7 yet. So put those in there, and that would be my union. What's in B intersect D? So keyword being and here. So I set up my bracket for my set. What elements are in both B and in D? B is 2, 4, and 6, and D is 1, 3, 5, 7. So I didn't say any number 2 times. There's no element at all that's in common for these 2 sets. So I can just set up the braces and leave them empty. That's the empty set. Or I could use my O with a slash through it, meaning the empty set. And what that tells me is that tells me these 2 sets are disjoint. Sets B and D are disjoint because they have nothing in their intersection. If we were to draw them out, they would be 2 non-overlapping circles. Okay, the next set is the set A intersect D, all in parentheses, and then the complement of that. If you get something like this, I recommend working from the inside out. First, figure out what A intersect D is. So I'm going to write that below. A intersect D. So what is in both A and in D? That would be the elements 1 and 3. That's what's in both of those. So what's in their complement is everything that's not that. So I need to list everything in the universe that's not 1 and 3. That would be 2, 4, 6, 7, 8, 9, 10. And lastly, we have A union B union D. So a bunch of ors. What's in A or in B or in D? I'm going to list everything in A. So 1, 2, 3, 4. Those are definitely in there. Or anything in B that I haven't said yet. So I haven't said 6 yet. And then anything that's in D that I haven't said yet. So I've already said 1. I've already said 3. I haven't said 5 yet. And I haven't said 7 yet. So add those in there. So it looks like A union B union D is the set 1, 2, 3, 4, 6, 5, and 7. And again, remember, ordering doesn't matter. So the fact that those last few are kind of out of numerical order is just fine. Something that students have trouble with is remembering which symbol means or and which symbol means and this is the way that I remember those. I remember that or, the union, looks like a bucket. It's the one that's like a right side up U. It looks like a bucket because the ors always have so many elements. So I think like many elements to carry. I'm going to need a bucket to carry all of those because the unions end up being everything that's anywhere in there. So you end up usually with a lot of elements. And then the and is the upside down bucket because you're not going to have as many elements in your intersections. So you don't need this like big bucket to carry them. And I don't have any fancy fun way to remember that one. I just remember that or is the bucket because I'm going to get so much stuff in there. And then and is the other way around. And looks like an in, and they kind of sound the same.